One of the most important concepts that you are going to have to deal with in the world of instrumentation is going to be pressure. As you can see on this slide, there are many different categories of pressure that can be measured, and I'd like to go into them individually. In front of you, you have the planet which we live on, Earth, and I've gone and drawn Earth with the atmosphere around us, that is the air which you and I are going to breathe, and then the black area that you can see is going to be a vacuum. Now, atmospheric pressure is going to be the weight of the force of the air above us that is pushing down. If you happen to live in London or New York or Perth or Brisbane or Auckland or Dubai, you're living at sea level, and therefore the atmospheric pressure that you are going to feel is the air weight above your head, and that's about 101.3 kilopascals, and you can go and convert that into PSI if you'd like to. I happen to live in the Highveld region of Southern Africa, and we live at an altitude of about 1,500, 1,600 meters above sea level. Now that means that the weight of the air above my head is less than the weight of the air above your head, probably in the order of about 87 kilopascals. So the atmospheric pressure for me is going to be different possibly to what the atmospheric pressure for you is. We're born with this, we don't notice it, but it is going to be around us all the time. So in space, we are going to have a vacuum, and then when you get to Earth, you're going to have the atmospheric pressure. And that atmospheric pressure can be high at sea level, or it can be low the higher you go up the mountains. The atmospheric pressure is going to be dependent on exactly where you are located. The next important pressure measurement is going to be gauge pressure, and often you'll see a pressure such as 300 kilopascals with the letter G in the background. That means that it has been represented as a gauge pressure. Gauge pressure is the pressure that we are going to measure higher than the surrounding atmospheric pressure. If I happen to have a pipeline with a pressure gauge connected to it, and that pressure gauge shows me 300 kilopascals or 3 bar, then we know that the pressure inside that pipeline is 300 kilopascals or 3 bar higher than the surrounding pressure. How does the instrument do that? Well, the instrument is just going to take its reference to the atmosphere around it. So the reference to the atmosphere is going to be open, and it just measures what that pressure is going to be. So whenever you see a gauge pressure, which by the way is probably about 90% of the pressure measurements that you and I are going to take, that just tells us what the comparison is of the pressure you're measuring to the surrounding air pressure in the vicinity. So to get back to this image of mine, we can go and say that gauge pressure is going to be any pressure which is higher than the surrounding atmospheric pressure. There's my atmospheric pressure. And then we're going to have the gauge pressure. Gauge pressure is any pressure greater than the surrounding atmospheric pressure. Another important pressure measurement that we can go and take is going to be absolute pressure. And in the case of absolute pressure, rather than having the reference open to atmosphere, the reference is going to be to a vacuum. So an absolute pressure is any pressure greater than a vacuum. If I was to get back to this sketch of mine over here, we can go and say that in the case of the absolute pressure is going to be calculated as the gauge pressure plus the atmospheric pressure. Now, we're often going to use these for calculations where you might want to compare something in one area to something in a different area where the atmospheric pressures are going to go and differ. That's going to be the absolute pressure that we can encounter. So to get back to this sketch of mine, let's go and say that the atmospheric pressure is going to have a value of 1 bar. If I have a gauge pressure that is going to be anything higher than atmospheric pressure. Let's go and say that I happen to have 3 bar inside that pipeline of mine. A gauge pressure is going to measure that as 3 bar if it is 3 bar higher than the atmospheric pressure. The absolute pressure is going to be the atmospheric pressure plus the gauge pressure. So in this case, it's going to be the 1 bar plus the 3 bar, which means it's going to give us a value of 4 bar. And always in the background, we put that little letter A just to specify that we are dealing with an absolute pressure. For many of us, we're going to take a flow measurement. Now, you might use a restricting device such as an orifice plate in your pipeline. That orifice plate causes a drop in pressure, and that will result in the differential pressure that we can go and measure to calculate the flow. Question that's often asked is, do we have to work in gauge pressure or can we work in absolute pressure? And my answer to you is that it's going to be immaterial. Let's go and say that the atmospheric pressure is equal to 1 bar and the gauge pressure upstream, let's go and put in hypothetical values of 5 bar, and the gauge pressure downstream is going to be 2 bar. So the differential pressure is going to be the 5 minus the 2, which gives me 3 bar. That will be the difference. Now, what if we'd gone and worked in absolute pressure? If I was working in absolute pressure, then the pressure upstream would be the 5 plus the 1, which gives me 6 bar. And on the right-hand side, the 2 plus the 1 would have given me 3 bar. The differential pressure in this case is going to be the 6 minus the 3, which still gives me an answer of 3 bar. So it's immaterial whether you work in gauge or in absolute, you're still going to get exactly the same answer in your equation. Please do follow me for more exciting videos after this one.